Hello class, so we are going to look at logs day 7 application, so some word problems. All right, so we're bringing back some of these old formulas. You do not need to memorize these. They will be given to you if this is the problem that you will see. And it's the same exact thing. So it's this, the P is still that initial amount, the A is still the ending amount, the R is still the rate. If we do compound interest, the N is still the number of times compounded per year. T is still time. And for PERT, this is when, again, remember, it says compounded continuously. The only difference is this unit, we're going to be solving for something that's in the exponent. And in order to do that, we need to use logs. I'm only going to go over a couple of these because really there's not a ton on the test. They might be extra credit, so it's just going to be kind of a quick recap. So I'm going to skip example 1. We're going to go to example 2. It says, how many years will it take the principal in an account that is compounded continuously at 3% to double? So the first thing I'm seeing is the words compounded continuously. Okay. So I'm going to write down the correct formula. Now, this one's kind of weird because it's saying how long will it take to double? It doesn't actually give us a starting amount or an ending amount, but what we know is the money amount has to double. And the only thing I know right now is the rate is 0.03. The time is what I'm looking for. And here's the weird thing. Since it's just saying how long will it take to double, all I need to do, I can actually make up an amount of money as long as whatever it starts with, then by the time it ends, it's doubled. So I could do like, oh, let's say we start with $100, then it has to turn into $200. I know this is going to be weird, but I always just say, let's start with $1, let's turn it into $2. And that's going to be the same as if I chose 100 and 200, and I'll show you why. I'm going to plug in 2 for the ending amount, 1 for the starting amount. E is just the number E. The rate is 0.03, and the T is unknown. Now, the first step is going to be to divide over whatever this number is. So let's say I had 100 here and 200 here. Well, 200 divided by 100 is 2. So no matter what numbers I choose, when I divide that number over, I'm going to end up with 2 on the left anyway, which is why I always choose 2 and 1. It's easier. Now, in order to get this exponent down, in order to solve for it, I'm going to natural log both sides. Okay. So I have the natural log of 2 equals, now I can drop down my exponent, 0.03t natural log of e. And as we know, natural log of e is 1. So I'm just going to divide over this 0.03. I have my answer. Natural log of 2 divided by 0.03 is 23.105. And we'll put years. All right. So that was example 2. Example 3, find the amount of time it will take for $1,500 to grow to $30,000 if $1,500 is invested in an account with 4.5 interest compounded bi-weekly. Bi-weekly is every other week. Kind of sounds like it would be twice a week, but we'll go with every other week. 52 weeks in a year divided by 2 is going to be 26. So the N is going to be 26 in this problem. All right, so we have the apparent formula. Okay. All right, so the ending amount is 30,000. The starting amount is 1,500. 1 plus the rate, 0.045. Bi-weekly is every other week, so 26 times. And then 26 times t. All right, so here's the deal. We're going to divide over whatever this number is in front first. That should always be our first step, is divide that over. $30,000 divided by 1,500 is 20. Now, I'm also going to type in my calculator everything in this parentheses. 1 plus 0.045 divided by 26. Okay. And you really don't want to round this number. I'm just going to write this, okay, to the 26t. And what I'm going to do is natural log both sides. Okay, so I have the natural log of 20 is equal to, drop down that 26t, natural log of this answer cool. And now I want to get the t by itself. So I'm going to divide over to the other side both the 26 and the natural log. You can divide them over together. You could do it one at a time. It doesn't matter, actually. Okay, so I'm going to divide that over to the other side. Okay, here it is. Here's how I'm going to type this in. Natural log. Natural log of 20 over 26 times the natural log of this answer. And that should give me my answer. Because the 26 cancels, the natural logs cancel, I'm just left with t. It's a lot of years. 153.42 years. I mean, it makes sense. It's growing from 1,500 to all the way to 30,000, only at 4.5% per year. So it's going to take a really long time for that to happen. All right, so there's those two examples. And I'm going to skip example 4. We're going to go to example 5. And this is just your basic, kind of like what we saw in the mini quiz. This is your basic exponential growth or exponential decay. And again, whichever formula you're going to have to use, we're going to give you. This one says you run a very popular Instagram account, and in 2020 you have 120,000 followers. If the number increases by 15% each year, what year will you have 300,000 followers? Okay. So the number of followers is growing, so we're going to use a basic exponential growth function, which means we're going to have a plus sign here. Okay, so we want it to grow to 300,000. Right now, it's at 120,000. And your growth rate is 0.15, 15% per year. We're looking for time, okay? It's saying let F represent the number of followers, so that could be like this. It doesn't really matter. I'm using that growth model, and your first step is always to divide that starting amount over. So 300, 1, 2, 3, divided by 120, 1, 2, 3. 2.5. All right, 1 plus 0.15 is 1.15 to the t power. And now I'm going to natural log both sides. So I have the natural log of 2.5 equals, drop down the t, natural log of 1.15, and divide the natural log over. So I have natural log of 2.5 over natural log of 1.15. Okay, so that's about 6.556 years. There it is. Okay, so the word problem on the test, like I said, is extra credit. It's going to be kind of similar to something like we saw on our mini quiz or example 5. If I do give you a compound interest one, I would assume it would be more of the compounded continuously, but we will give you the formulas. So it shouldn't be too bad. Hopefully this makes sense. Go back, rewind, rewatch if you need to. And that's it. So sorry I can't be there to teach this, but hopefully it's all, the math is mathing. All right, we'll see you soon, hopefully. Bye.